Hi everyone, welcome to your video lesson on 12-2, angles and angle measures in the coordinate system. So in this lesson we're going to talk about how we can take angles and place them in the coordinate system, right? So our x and y axis we're usually used to placing coordinates or functions, but in this case we can also position angles in them. And there's a couple of rules about how to do it. So the first thing is that you'll always place an angle in the coordinate system in its standard position. So the standard position is that the vertex is at the origin right here, and that the first ray of your angle must always start on the initial side. Okay? That initial side always lines up on the x-axis, on the positive x-axis side. So this initial side is where your rotation starts, and then the other ray is called the terminal side. That means that's where the rotation finishes. Okay? So if you're rotating a positive direction, you'll rotate counterclockwise. If you're rotating in a negative direction, you'll rotate clockwise. Now, the reason that we go in this direction is really easy to remember if you think about your quadrants. So remember that this is your first quadrant in the coordinate system. That's the positive quadrant. This is your second quadrant. This is your third. And this is your fourth. And so if you remember that, then positive rotation always goes through the quadrants in numerical order. First, second, third, fourth. First, second, third, fourth. Negative rotation will go through the quadrants in reverse order. So fourth, third, second, first, fourth, third, second, first. Okay? When we start to look at different angles around the coordinate system, we realize that there are special, what we call quadrantal angles. These angles are special because they occur where the quadrants change. So if you rotate 90 degrees, you end up on the positive y-axis. If you rotate 180, you end up on the negative x-axis. And if you rotate 270, you end up on the negative y-axis. The quadrantal angle for 360 is if you go all the way around and come back to where you started. Okay, so these are called the quadrantal angles. They're really important because they're going to help us kind of have checkpoints to figure out where our terminal side is going to end up. Okay? So if my angle of rotation is 100 degrees, I know that that occurs between 90 and 180, and so my terminal side should be somewhere in the second quadrant here. Okay, so that's why these quadrant numbers are really important. Okay, and we talked about rotating positively versus negatively. So let's look at a couple of examples where we are going to have to position or sketch angles in the coordinate system. So pretty much for all of these, anytime you're positioning an angle in the coordinate system, your initial side is going to be on the x-axis. So you can pretty much set yourself up every time with that side ready to go. Okay, so there's my initial side for this one. And we're only rotating 36 degrees. So what I like to do, especially the first couple times I'm doing it, is just remember where my quadrant angle measures are. So because we're rotating positively, I'm going to label my positive quadrantal angles. Positive 90, positive 80, positive 270. So this one's fairly simple. We know 36 degrees is a relatively small amount of rotation. So I'm not even going to get past the first quadrant. I'm going to be stuck in the first quadrant here. My terminal side, we'll get a different color, is going to be approximately here. And this is in the first quadrant. And so just to make sure that you understand what we're describing the amount of rotation from this initial side here. And I'm going to give it a direction so that we understand that this is starting here and rotating there. Okay? So that's a 36 degree angle. All right, pretty simple for a positive one that's very small, but let's try one that's negative. So in this one, letter B, I'm rotating negatively, so I still start with my initial side on the x-axis. But when I label my quadrants now, I want to think, okay, I'm rotating clockwise, so that means I'm going this direction. So I'm actually going to label my quadrants differently. If I rotate negative 90 degrees, that would be down here. If I rotate negative 180, that would be here. and this would actually be negative 270. Okay, so because we're going in reverse order now, I've got to reestablish my quadrantals. And so negative 315, if I went all the way around, that would be negative 360. Negative 315 is between negative 270 and negative 360. It's actually exactly in between them. So now I can label my terminal side. It's going to be right in between. And this is where drawing the direction is important, because we didn't start here and just rotate positively to this terminal side. We rotated negatively. So I need to show the rotation going all the way around through all 4 quadrants. Okay, so that amount of rotation all the way around, that's negative 315 degrees of rotation. Okay, let's look at letter C. Letter C, very similar. We're going negatively, so I'm going to label my quadrants negative 90, negative 180, negative 270. Negative 360 gets me all the way around back to the x-axis. So like I said before, always label your initial side. And then negative 150, that's between negative 90 and negative 180. So I'm actually going to be down here in the 3rd quadrant. And then I'm going to show my rotation. So again, going negatively means I'm going clockwise to this terminal side. Okay, and that's negative 150 degrees. For 180 degrees of rotation, that is actually a quadrantal, so we'll end up on one of the axes. Don't forget your initial side, always on the x-axis. Because we're going exactly 180, I know that it's going to end up going in the opposite direction. These are called opposite rays, if you remember that from geometry. But this is where it's important to show the direction we rotated was this way, in the positive direction, which is counterclockwise. So this is a positive rotation of 180 degrees. Okay. For letter A, they've given us 4 angles, 3 of which are coterminal. What that word means, coterminal, is it means that they end in the same exact position. So you may have thought of this already, that sometimes some angles, their terminal side will end up in the same position regardless of the direction that they rotated in. So how do you figure out which one's not coterminal? Well, easy way for me to do it is just to graph them all. If you plot all of them, you should be able to tell which one is not going to line up with the other 3. So they all start in the same position. They all start on the x-axis right here. 2 of them are positive, so we'll do those first. 60 degrees, let's start with the easy one. If it's a 60-degree rotation, it doesn't even hit my first quadrantal at 90, so I know that the letter C is going to be in the 1st quadrant. I'll estimate it there. And then we'll draw our rotation. Okay. 300 degrees, which quadrant would that be in? Well, if you need to, you can relabel your quadrants. 90, 180, 270. And then all the way back around is 360. So 300 degrees is between 270 and 360. It's actually really close to 270, or closer to 270. So my terminal side should be down here somewhere. How do I show that rotation? Starts here, rotates all the way around 300 degrees. So I can already tell that these are not coterminal with each other. So now I just need to figure out which of the 2 is coterminal with the other 2. Okay. So let's graph negative 60. So negative 60, if you need to, you can reset up your quadrantals in the negative direction. This would be negative 90. Which means that negative 60 is going to be down here in this 4th quadrant. And in fact, it actually ends up being right on this terminal side right here. So this is negative 60 degrees of rotation. So right there, if 300 and negative 60 are coterminal with each other, that probably means C is going to be my correct answer. It's not coterminal with the other ones. But if you want to check negative 420 to see that it ends up with the other two, if you rotate negative 360, you would end up all the way back here, and then you'd have an additional negative 60 to go to get back where you started. So you can actually rotate more than 360. Okay. Question B, which angles are coterminal? Okay. One of the easy ways we can tell that angles are coterminal is that they are separated by 360 degrees. So if you want to, instead of having to graph these, you can just add or subtract 360 and see if you get the same number. If angles are 360 degrees apart, they are considered coterminal, meaning that they will end in the same spot. So mathematically, the faster way of doing this is if I take negative 315 and I add 360 to it, that should give me a coterminal angle. Negative 315 plus 360 is equal to 45 degrees. So that means negative 315 and 45 are coterminal. If I want to find another coterminal angle, I've got to add another 360 to it. 45 plus 360 is 405, so that means D is also coterminal. Notice that we did not line up with positive 315, so this one is not coterminal. Okay, you could also just plot them and see as well. All right, that's going to finish our first half of this lesson. Check out the second video for our second page of notes.